Well, good morning or good afternoon, depending upon where you are. I'm grateful to have this opportunity to present in this water forum. And I wanted to share with you today, and instead of giving a presentation with regards to the Corps of Engineers' role in, for example, watershed management and flood risk management, I want to focus on a particular research and development effort that's ongoing that I think will be of great interest, particularly since this forum is focused on water innovation. So the title of my talk is Assessing the Viability of Forecast-Informed Reservoir Operations. And this is a multi-agency research and development effort that I think will become clear as I move along. Just to orient you, I work with the U.S. Army Corps of Engineers, the Engineer Research and Development Center. So that's the R&D arm of the Corps. There are 7 different laboratories that you see listed there. 4 of them are in Vicksburg, Mississippi, and then there's 3 in other locations, Hanover, New Hampshire, Hanover, New Hampshire, where the Cold Regions Lab is, Champaign, Illinois, for the Construction Engineering Research Lab, and the Geospatial Research Laboratories in Fort Belvoir, Virginia. The others are all in Vicksburg, Mississippi, where I am, in the Coastal and Hydraulics Lab. We focus on different R&D mission areas. Many are supporting to the military engineering, geospatial research and engineering, environmental quality and installations. Those are all areas that focus on the military. But then civil works and water resources is the R&D area that I focus in. So what we're going to talk about today, we need to get a definition out of the way first, and that is we're going to talk about what atmospheric rivers are and how they impact, potentially impact the change in how reservoirs can be operated, particularly in the West. And so what an atmospheric river is they're essentially a finger or a narrow band of tropical moisture that's been pulled up into higher latitudes. And these tend to impact in the West, although I'll show you later that that's not the only area that they impact, but they carry a tremendous amount of water, up to 10 Mississippi rivers, for example. And in California, generally, they provide between, up to about half of the annual rainfall come from these type of events. Right now, and I hope this animation is able to be viewed across the web properly, but this is actually the latest, I pulled this morning, that you can see that there's an atmospheric river that is delivering moisture to the west coast of the United States. And so you may have been hearing about rainfall in California and in the Pacific Northwest, and that will continue actually through the weekend. You can see all this moisture is making its way up there. So these are the large events for the West Coast. So why atmospheric rivers matter in the West is that they play the large-scale events, the flooding events that occur in the West are generally atmospheric rivers. This paper here focused on the Russian River, which is north of the San Francisco Bay Area, that in the past 8 years, all 7 floods that occurred on that river were associated with atmospheric rivers. A further study showed that in western Washington, 46 of 48 annual daily peak flows on 4 different watersheds were all associated with the landfall of atmospheric river conditions. And so these events are the ones that are their main drivers in terms of flood risk, in terms of things that dam operators would be concerned about in terms of making sure that there's storage for floods, as well as then how you balance that with the need for storing water for water supply and other such things. So I mentioned that they mainly impact they're the largest impact is on the West Coast because these are the source of their major events. But that they don't only impact the western United States. In May of 2010, there was a flood in Nashville, Tennessee, that many of you may have heard about, caused tremendous flood damage there. That was an atmospheric river. The ones that occur on the West Coast tend to be called pineapple expresses because they come from the direction of Hawaii. But when they occur on the Gulf Coast or in the southeast of the United States, they tend to call these Mayan expresses because they come from the direction of the Yucatan Peninsula. They can also occur on the East Coast. In 2010, February of 2010, the Snowmageddon event, as it was called by some, that paralyzed much of the East Coast, that also had the signature of an atmospheric river event coming out of the Gulf of Mexico area. So the Nashville event, what made that one such an impact was that there was not just the presence and the vertical transport of this water vapor, but there was also this a mesoscale stationary convective pattern set up to drop that water out and to focus the location that dropped it out right on Nashville, essentially, which caused that major flooding that occurred there. Just this year, in March, there was some major flooding that occurred in central Louisiana, in the area of Monroe, Louisiana, just about 80 miles to my west of here from where I am in Vicksburg. That was a Mayan Express. At the same time, you had a Pineapple Express impacting the West Coast. So these weather events are very, understanding them, understanding how they work is key to being able to predict into the future about how we might, how water resources and how dams can safely be operated in major events, but then also find a way to have to be able to increase water supply going forward. So the Corps of Engineers has a very important flood risk management mission. And so life loss and property damage risk reduction are very, very high priorities for the Corps. And the Corps has a robust and very effective dam safety program to ensure that flood risk is minimized. And so how that's often done is that each dam, each Corps of Engineers dam, and there's over 700 of them, by the way, they each have a rule curve, and that rule curve dictates the operations at that reservoir based on flood risk management principles. And so it works like according to this graph that you see here, that when the water level is below the dashed line, then it's what we call the water supply pool. And usually a local agency, a partner agency, will operate the dam at that point. But if the water level rises up to the level of the dashed line, and this particular one here is for Lake Mendocino in California, which we'll talk about more in just a minute, but running for the water year from October 1 through September 30, the dashed line changes the water level changes based upon this is the wet season of the year, so large rainfall events occur here, and so therefore there needs to be more flood control space to be able to store large events if they occur. But in dry times of the year, then the reservoir is allowed to be much higher because the occurrence of large events in those times of the year is very, very minimal. So with Lake Mendocino, that's the guinea pig for this effort, this forecast-informed reservoir operations effort. You see on the left here the watershed for the Russian River, and Lake Mendocino is located at near the top of the watershed. And so it really only captures water from this upper, the northeast corner, if you will, of that watershed. And on the plot on the right, you see the dashed line indicating the rule curve, the maximum allowable storage, depending upon what time of year it is. And we're looking at the red line plot is the water year of 2013. And so as it approached into December, the dry season ended and rain events occurred due to atmospheric rivers. Two very large events occurred in December that brought the water level well into what is the flood control space. And so by the rule curve and the operations manual that exists for this reservoir, that water was then released to get back down to the dashed line, the safe level. But what we didn't know at the beginning of January in 2014 was that it wasn't going to rain again for a very long time. In fact, the next 15 months are some of the driest on record anytime for any 15-month stretch for that part of California. So the question is that if we had known that it wasn't going to rain anymore, if we had a reliable way to predict that and to know, then maybe we could have not let all of that water go, but stored at a higher level so that if we saw a large event coming, then we would be able to release back down, get back down to our safe level. And so that's the whole question with this R&D exercise is, what kind of forecast capability do we need to be able to safely and reliably make those kinds of decisions? And so that's what this effort is all about. FIRO, or Forecast-Informed Reservoir Operations, is about using advanced hydro-meteorological forecasting capability to inform water supply and flood control operations at reservoirs where atmospheric river events frequently and predictably occur. And so we're exploring then better balance between flood risk management and water supply and ecological needs. And so the scope of this effort is using data from watershed monitoring and weather forecasting capability to inform management decisions to either selectively retain or release the water in a manner that reflects the current and forecasted conditions. And so we've got a 5-year proof of concept project using Lake Mendocino as our test bed to develop a process that can be used to test FIRO, not just there, but at anywhere that might be affected by atmospheric rivers or any other phenomenon too that can be predicted in the same way. But we're focusing again on this watershed and this particular phenomenon because of the impact that they have in that area. This pilot project, if you will, was highlighted in the White House report that came out in March on page 3 under the piloting promising solutions section. The first bullet there is this effort as it's described. And it mentions there that there are numerous partners in this effort. And this truly is a very collaborative effort between federal, state, and local agencies. So you see that we have 3 different elements of NOAA as the research as well as operations and marine fisheries service. Then we have the USGS, the Corps of Engineers, and the Bureau of Reclamation are all participating with the relevant portions of those areas, whether it's research or whether it's operations. We have representatives from from those agencies participating in this. And of course, we've also got the California Department of Water Resources. The state climatologist is participating in this is on the FIRO Steering Committee, as well as we have the Scripps Center for Western Weather and Water Extremes at the University of California, San Diego, where Marty Ralph, who's one of the world's leading experts on atmospheric rivers, is engaged in this effort. And then, of course, our partner locally is the Sonoma County Water Agency, who operates Lake Mendocino's dam when it's beneath that dashed line, when it's in the what we call the water supply space. And there are also, of course, NOAA Habitat Blueprint effort ongoing in the Russian River right there. So the ecological concerns are also folded into this effort. Now, I do need to say that just because we're studying it doesn't mean that something is broken. So the R&D is being conducted to determine if there's sufficient capability now or in the near future to reliably and formally incorporate forecast information into water operations decisions. This is being done already in some places. In fact, Folsom Dam, which is jointly operated by the Corps and the Bureau of Reclamation, is incorporating current forecasting capability into their new water control manual for that dam. This is a little bit different. This is focusing on future capability, particularly looking at what would be needed in predicting atmospheric rivers to be able to incorporate those into water operations. So current water control manuals and core water management policy continue to provide appropriate levels of flood risk management. We have a very, very good track record in that. And so just the age of a water control manual is in and of itself is not an inherent problem. But the question is that with current or with future forecasting capability, can that be incorporated and how should that be done? And so those challenges are then the researchers involved in this effort, we need to develop forecast models and tools that are tailored to provide improved forecasts for weather events such as atmospheric rivers such that they are suitably reliable for operations decisions. You know, when you're making that decision whether or not to release the water or not, that's very different than a forecast. A forecast, you know, has obviously you're trying to warn the public about potential. Water operations, when you release the water, water is going to flow down that waterway, and therefore there are consequences from that. People could be flooded, property could be damaged. So FIRO researchers need to develop improvements to current hydrologic and reservoir operational tools that will meaningfully enhance the simulation of these events for water supply, flood risk management, and ecological considerations. And so the real goal of this effort is to provide the required key data points to inform the operational policy decision makers within the Corps of Engineers with respect to how this could be folded in. So how that's being done is the multi-agency steering committee for this effort developed a work plan which lays out a roadmap for 5 years. It was finalized last September, and it provides the roadmap of how we're going to conduct this. And essentially, it's this. That is that we were initially conducting a preliminary viability assessment to determine whether or not the current capabilities are meet the needs or not. Are they viable to be able to incorporate them into reservoir operations? If they are, great. Then we will focus on the orange box here of how do we do that? How do we incorporate that into the water management process? If they're not, then what science and decision tools are needed so that they can meet the needs of water managers? And that, of course, leads into this development of the science and technical programs. This pretty much has the same kind of information laid out just in a time frame. And so right here, where we are is we're completing this preliminary viability assessment. That's ongoing right now. The report is being written, in fact, and we will then refine and define what those scenario testing will be for years 2 through 5 of this effort and identifying the research activities. And then conducting the full viability assessment of that will be what happens in the years to come. And so with that, I think my time is up, and I think we now will have, I guess, questions for the whole forum.